Hi friends, welcome to SriSai IT Hub. In this video of Core Java Programming, we are going to discuss the following topic: HashSet class in Java Collections Framework. So first of all, we'll have a small revision. What are collections framework in Java? So Java collections means collection of objects or a group of objects as a single unit or single object in a Java program. Then what is framework? So framework means library which is provided by Java in the form of packages to work with Java collections. And this library is available for us as java.util package. So in this java.util package, we have different classes and interfaces and its corresponding methods using which we can work with Java collections, collection of objects. So in collections framework, we have collection interface as a top level or a base interface for all the collection classes and its corresponding interfaces. So under this collection interface, we have four popular collections. First one, list collection. Second one, set collection. Third one, queue collection. And fourth one, map collection. So all these collections are interfaces. These are sub interfaces for collection interface, which is a top level collection interface, base interface. So coming to some technical points. So collections is only for collection of objects but not primitive data types. So if we add any primitive data type data, integer, character, boolean or floating number, it will be stored in object format only. So everything data which is stored in collections is stored as object class, object format. Right. So now coming to HashSet. So HashSet in Java collections framework. So first of all, it is available in java.util package, and HashSet class is inherited from set interface. HashSet class is inherited from set interface. Okay, right. So here it is inherited from set interface, and set is inherited from collection, and collection is inherited from iterable interface. Okay, and this class is also clonable and serializable. It is also inherited interfaces. So clonable means using clone method we can create a duplicate HashSet. Serializable means HashSet object can participate in serialization using write object method and deserialization using read object method. So all the methods of iterable are inherited to collection, and collection interface methods are inherited to set. In set we don't have any extra methods, so HashSet uses all the methods which are available in collection and iterable. Right, so coming to some technical points related to the HashSet. So HashSet is a collection of objects which represents same like mathematical set. Example, a mathematical set, object 1, 2, 3, 4, 5. So its initial default capacity is 16. Its initial default load factor is 0.75. So what is this load factor? So load factor, okay, it decides capacity. So it decides capacity of HashSet. So how it decides the capacity of HashSet? We'll take a small example. So let us say that capacity, so current capacity into 3 by 4. 3 by 4. So if we take this, so current capacity is 16. So 16 into 3 by 4. So 12. So when we add 12th object, automatically the capacity becomes double. So when 12th object is added, capacity becomes double. So double means 16 plus 16, which is equals to 32. Similarly, 32 into 3 by 4, which is somewhere around 32 into 3 by 4. So 24. When you add 24th element, automatically it will become 32 plus 32, 64. Like that. And in HashSet, it does not provide indexes in the collection of objects. So no indexes, and HashSet does not accept duplicate objects. And next, in HashSet, order is not preserved for collection of objects because internally it uses a hashing technique to store the order for collection of objects. Right. So now coming to the constructors and methods. So if we see the description of HashSet, Java p -p java.util.hashset, open the command prompt, go to your working directory and issue the command. Right. So here coming to the HashSet, so HashSet is inherited from set. So set is inherited from collection. Collection is inherited from iterable. And next it is also clonable and serializable. So coming to the constructor, so this is a constructor with a default capacity of 16 and default load factor 0.75, 3 by 4. And this is a constructor with int. Int indicates our own capacity 20 and default load factor will be 0.75 only. And this is the constructor int comma float. So float, int is the given capacity and float is the given load factor. So generally we give load factor from 0.5 to 0.9. 0.5 to you can give 0.99 but not less than 0.5. So load factor decides the capacity increasing of a HashSet. Right. So coming to the methods, size, it will give the size of the HashSet. Is empty, checks whether HashSet is empty or not, true, false. Contains object and returns true or false. Adding an object and returns true or false. Removing an object, clearing completely all the elements, deleting all the elements, and cloning. So these are some important methods from the HashSet. Right. So these are the constructors and methods. So let us try to demonstrate this with a small program. So we'll take a program, HashSet class example1.java. So take a new page. So first we'll write the comments, program to demo HashSet class with collection of objects. So import java.util package. So take the main class with main method and save the program as HashSet class example1.java in your working directory. So initially we'll create a HashSet, hs is equals to new HashSet. So initial default capacity is 16 and default load factor is 0.75, which is 3 by 4. So when 3/4 of the elements are added, 16 into 3 by 4, 12, automatically that capacity will become double. So 16 plus 16, which is equals to 32. It keeps on increasing, doubling. Right. So initially HashSet will be empty. Initial size will be 0. Is empty, true. So let us execute till here. So let us put a comment here for the remaining cases. Next, go to the command prompt, save it, compile. So HashSet class example1.java and run it. Java HashSet class example1. So initially it is empty and then size is 0, is empty, true. So let us add some elements into the hash set. HashSet dot add of 11, 22, 33, 44, 55. And once again we'll print hash set, size will be 5, is empty, false. Save it, recompile, and run. So now we have 5 elements. Order is not preserved because of hashing technique, which is used by JVM to store the elements in a hash set. And then size is 5, is empty, false. Next, we'll try to remove 22 and then print the hash set once again. So hash set dot remove of 22. So 22 is there, it will be removed. If it is removed, then print, it will return true. So true means given element is removed, else given element is not removed, and once again print the hash set. Right, so save it, recompile, and run. So 22 is removed, and then we have only 4 elements without 22. So let us try to remove another element which is not available, something like 222. So 222 is not available, it will return false. So when it returns false, given element is not removed. Again you will have the 5 elements. So recompile and run. So given element is not removed, so we have only the given initial 5 elements. Right, so next let us go to contains. Fine. So hash set dot contains. So here we'll remove initially 22, given element will be removed, you have only 4 elements now. Right, after that hash set contains 22. So 22 is not there, given element is not found because contains method returns false, true. Okay, right, so 22. So 22 is not there. In this case, you will get given element is not found. Right, so simply compile this and run it. So 22, given element is removed. After that, we have only 4 elements. Given element is not found in the hash sets. Next, if we take something like 44, so 44 is available. Save, recompile, and run. So 44, given element is found in the hash set. Next, now since we have only 4 elements, again we'll add 22. So it goes like this. So hash set dot add of 22. So when we add 22, it will return true. So it will print it true. After that, print the hash set once again. Let's just save it, recompile, and run. So 22 has added true. So again 22 is available in the hash set. Next, we will add 22 once again. So hash set does not accept duplicates. So when you try to add 22 once again, it will return false. And once again print the hash set. Right, save it, recompile, and then run. So false because it cannot take duplicate objects. Hash set is as it is with 5 elements. Next, we'll create a duplicate hash set. Right, so hash set duplicate hash set is equals to hash set dot clone. Return type of clone method is object class type. Convert that into hash set subclass type or downcasting, and store the reference in duplicate hash set and print duplicate hash set. So save it, recompile, and run. So this is the new duplicate hash set. Order is not preserved because internally it uses the hashing technique to store the order of collections in a hash set. And next, so here order may change, right? So next we'll say HashSet dot clear. After that we'll print HashSet, no elements will be there. HashSet dot size 0, HashSet dot is empty. You will get it as true. Right, so save it, recompile and run. So after clearing, no elements, size is 0, is empty, true. So this is how we are supposed to work with HashSet collection under set collection in Java collections framework. Thank you for watching this video. Do like, comment and share this video, and also subscribe to the YouTube channel Sri Sai IT Hub. Have a nice day.